All right, guys, we're going to get started here. Because we've got a lot to cover, I'm going to go ahead and get started. So thanks everybody for coming. Today I'm going to talk through how to one-up your Git skills. So based on the survey, I was pleasantly surprised to see that everyone thought that they were between pretty much a 3 and a 4. So that's a good thing. Everybody feels pretty confident with Git. So hopefully this talk will help move you guys up to the 4 or 5 level. So the takeaways that I'm hoping you guys get from this talk are understanding the two main schools of thought for commit history, understanding the 3 GitHub PR merge options which they've introduced in the past year or so, understanding common gotchas with rewriting history with some of those options, and master or learn a few new Git commands. So plumbing versus porcelain, we're going to pretty much stick to the porcelain commands on this. Like, I'm not going to dive deep into how Git works under the covers. A few of you commented that you were interested in learning more about how Git like manages stuff and does the merges and generates SHAs and that kind of stuff. I'm not going to dive into that here. There are docs on the plumbing of Git that could be really interesting to you. And there's also a book I recommend at the end if you want to learn about how Git actually works under the covers. So, a tale of two histories. There's sort of two main schools of thought on commit history. The first school is basically that it's a record of what actually happened. The quote that is in the Git SCM book is that it's a historical document valuable in its own right and shouldn't be tampered with. From this angle, changing the commit history is almost blasphemous. You're lying about what actually transpired. So what if there was a messy series of merge commits? That's how it happened, and the repository should preserve that history. In my opinion, this gives you such classics as initial commit, merge conflicts, fix, or my personal favorite. That's a good one. So some of these, of course, are shown in jest. The messages could be improved, and that would get us farther along. And it is really a record of what happened. Somebody really was feeling that way when they committed that code. However, the historical record is sort of difficult to traverse when we've got a bunch of micro commits that look like this. The next school is that it's a story of how your project was made. So you wouldn't publish the first draft of a book or a talk. And the manual for how to maintain your software deserves careful editing. This is the camp that uses tools like rebase and filter branch to tell the story in the way that's best for future readers. Which gives you commits more like these. This was automatically merged. This was a squash and merge from GitHub. It has the name of the PR, a link to the PR, a nice long comment, and a story link, which is pretty handy. And even if you don't do, like, even if there's not like a giant commit message with stuff like this is more valuable than like work in progress because it has a link out to the ticket in Pivotal Tracker. It has a link to the PR itself and a pretty descriptive title as to what the commit actually did. So there are pros and cons to both schools of thought. So for the first school, where it's a record of what actually happened, the pros are that it's really easy. Most people, I think, like 91% of people said that they were comfortable with the merge command in Git. So it's easy. There's low risk or barrier to entry. History records what truly did happen. But the cons are that there's lots of micro commits with varying levels of meanings, like our commit messages we showed before. And more commits also means that there's more time traversing the logs if you have to go back through the develop branch and see where a given feature or bug was integrated. So the other school says, the story. It's a story of how your project was made. The pros are that there's clean, meaningful history. There's no work in progress or initial or adding a test or PR feedback commits. But the cons are that you have to be careful with rewriting history. When you change the history from your branch as you merge it into mainline, there's some gotchas there, and we'll go through some of those later in this talk. And the other con is that it can kind of create macro commits containing a lot of code. So imagine that you have a PR or a branch where you're upgrading the framework that you're working with. So say you're going from Rails 4 to 5. That could touch a lot of files. And if you squash and merge all of those things into one commit, you kind of have this one giant macro commit that you can't really tell, what was uh, what were the individual things that changed. There's probably a bunch of commits, each commit fixing a deprecation warning or something like that, and those could be valuable, and a squash and merge might not be the right thing to do in that case. So does anybody have any questions on the two schools of thought before we dive in a little bit deeper? We'll go through some more of the pros and cons and stuff. So the next sections, I'm going to go through the 3 GitHub PR options. So when you're ready to integrate a branch, there are 3 options that GitHub exposes: creating a merge commit, squash and merge, and then rebase and merge. And we're going to step through a given example and sort of show what each of these options looks like as we integrate those PRs in. So the first one is create a merge commit. People said that they felt pretty comfortable with this one, so I'll go a little bit faster through this. The first thing to take a look at is that this is the example that we're going to go through in all 3 examples. So it's good to walk through this and kind of familiarize ourselves with it, because we're going to create a merge commit, rebase and merge, and squash and merge the same branch in these examples. So the way that this is set up is that Alice made the first commit there to develop at the very top with the commit SHA C1. Then Bob broke off a feature branch called add behavior, and he committed C2 and C3 onto his branch. Then back over here on develop, Alice committed C4. It's her unrelated commit. She was working on another feature and she integrated that into develop. And then Bob made one last commit called C5 on his branch. So this is a lot of text, and we're going to walk through it. I'm going to read through it, and then we're going to break it down. So when Bob merges his feature add behavior into the develop branch, it performs a 3-way merge between the 2 latest branch snapshots, C4 and C5, and the most recent common ancestor of the 2, which was C1, creating a new commit called C6. So that's a lot. We're going to break it down step by step. So the first thing that Git has to do is say, where are the 2 latest commits that we want to merge? That's Alice's commit C4 on develop and Bob's commit C5 on his feature branch. And these slides are all available, so don't worry about taking notes on this. Then we need to look at the most recent common ancestor. So where is there in the history that both Bob's branch knows about and develop knows about, which was C1 when the branch was originally broken off. So it does that. It creates a merge and merges his branch into develop, but it creates C6 that says merge branch feature add behavior into develop. So now Bob's branch is merged into develop. And this is fine, but we've produced another commit which might not really have value. Additionally, we have each of Bob's feature branch commits intermixed within the history of develop. So this is what develop looks like after our merge commit happens. So we have Alice's C1, Bob's C2 and C3 from his feature branch. Alice committed her unrelated commit, Bob's last feature commit, and then C6, the merge. So you'll notice that each of the steps along the way in Bob's branch are now a part of the develop history with the merge option. So does anyone have questions on how that merge happened or why? You'll see with the other ones that how it can be different. So next we'll walk through a rebase and merge. So again, we've got the exact same thing that we started with before. So a rebase takes one or more commits and reapplies it on top of the commits on the destination branch. So when we rebase Bob's feature branch off of develop, it works by going to the common ancestor of the 2 branches, generates diffs for each commit that he made, C2, 3, and 5, and replays each commit on his branch. So you'll notice that Bob's branch was originally broken off of here. He did these 2 commits. Alice had one on develop, and then he had his last commit. What a rebase is doing is it's going to the common ancestor. So this is where Bob originally broke his branch on C1. It generates diffs for all of his commits that he added onto his branch. It brings in Alice's unrelated commit and then replays these step by step. So we're rebasing, meaning we're taking the base of his branch from C1 down to the current tip of develop, which is C4, and then replaying each one of his commits. And you'll also notice that it does generate a new commit hash here. So instead of C2, C3, and C5, because Git generated diffs and replayed those commits, they get new SHAs. So 6, 7, 8. So then the merge occurs as a fast forward merge and thus creates no merge commit if you do the rebase and then an immediate merge. So someone noted in the like freeform section of the survey that they wanted to know what the term fast forward merge meant. A fast forward merge basically means that it doesn't have to look up to a common ancestor like we saw with the original merge when the branch didn't know about C4. We were branched directly off of C4, and then our commits were linear. So a fast forward merge says, I know everything about the history on the branch that I'm merging into, so I don't need to do an actual merge. All I'm doing is doing a fast forward merge, or basically directly pushing my branch onto develop. But with the rebase and merge, you'll notice that develop still has first feature commit, second feature commit, last feature commit. So the rebase didn't do anything with the commits, like we'll see with squash. All rebase does is breaks the branch, rebases it off of the most current tip of the branch that we're merging back into. So the result of the merge and the rebase are functionally the same, except the rebase history looks more linear, right? So here's our merge commit. It's not super linear. It's true to when Bob was actually making these commits in time, right? Because he made these before Alice in time made this commit. And so, like, it exactly represents what happened. But if you take a look at the rebase and merge, it looks a little bit different, but it also feels a little bit more linear, right? We've got Alice's commits and then a chunk of Bob's commits all at once. So, any questions on rebase, how that worked? Yeah. Right. So when you rebase, are the timestamps still the same as when they were originally made? They're actually rewritten because all Git is doing is it's generating a diff and then it's just reapplying that diff and creating a new commit. So that's part of the argument for the first school of thought is like you're rewriting history. This isn't when it actually happened. This is when you rebased. So that's one of the arguments against it. Any other questions on rebasing? So the last squash and merge, many of you know that we enforce this, and we'll talk through why we do that. So a squash takes one or more commits, creates a single commit from those commits, and then applies it to the destination branch. So again, the same branch diagram we know and love. So when we squash this branch, it conceptually rebases it just like we did in the last example. So it pulls the branch from being branched at the time of C1, it moves it down, sees Alice's C4, and then replays these commits, just like we saw before. But then it squashes those commits into one commit. So we actually see it looks like this. So all the commits from that branch are now contained in a single commit. So we're still on our branch because we're still going through the squash. We see C1, Alice's first, C4, Alice's unrelated commit. But now you'll notice that Bob's 3 commits are now all squashed into one commit with a new commit hash, C9. So then, just as before, it can occur as a fast forward merge because the rebase occurred. We know about all the history in develop, and then we can just merge Bob's commit C9 onto develop, just like a rebase and merge. At this point, you might have also noticed that the commit message changed, right? So within the GitHub interface, the way that it'll originally do this is if you have more than one commit on your branch, it'll show the name of your branch. It sort of like title cases it. And then it shows a star with each one of your commit messages in it. So it like tries to retain what you actually put in those. But one of the arguments against merging every single commit in is that a lot of those commits don't have value on their own, right? These might be work in progress, PR feedback, fixing a test, whoops, schema commit, right? Like all those random commits that are important for you to get fixed before you merge, but like don't really have value to be merged into the commit history. So I'm going to propose that you take a few extra minutes to add some thoughts about what the code actually does. Think about this as, again, the like rough draft of your story versus your final draft that you're actually going to publish. All of this is editable, and you should take the time to edit it and make it useful so that imagine a developer does a git blame, and 3 years from now, um, they will know kind of what happened, right? So add behavior to a given area of the app, kind of explain why are we doing this, because we have paying customers, they've requested this new feature, they want the widget to appear on screen when they click the foobar button. This commit introduces that behavior. Take the time to note anything that might be a gotcha. If somebody's blaming it, they might be wondering like, why did they do this? Or I found this issue that I'm curious about. So something like the previous caching behavior also notably needed to be modified when adding this feature. The PR with a link to the PR contains a great discussion between myself and another dev who works with me about the implementation. Finishes number 1, 2, 3 in my project tracking software. So this is like super valuable if somebody finds this, right? They can go look at the ticket. They can talk to the other person who works with you. They can go look at the PR and get the history. This is way more valuable than just seeing the starred commits, unless every one of your commit messages is very detailed, which I know mine aren't. So does anybody have questions on squash and merge? What it does? Mike. Here, let me get you the mic.
Yeah, maybe it's just the nature of the way the data science team operates in GitHub, but it feels like we generally track all that sort of information you put in the squash commit in the PR.
Mhm.
And like when we're looking back at history, I'll just go through pull requests because our commits there's 1,495 commits on the prod branch. So, um, it feels like you're strictly losing information by squashing since it's all in that PR already. But that's
Yeah,
just my thought.
yeah, definitely. And I think this goes to the two schools of thought. Some people will definitely disagree with the squash and merge. I'm gonna. There's a few more slides later on here that sort of try to prove my case a little bit more. Um, when you squash and merge, it still does link back to the PR, and you still have all of that commit history there. Um, the other thing that I do often is like we have a PR template that has a big background section. Often when I'm squash and merging, I copy paste the background section into my commit message. Um, I think it's really helpful to have that information at the commit level, not in the PR, because what if your PR was merged a year and a half ago, right? It's hard to find that. And with squash and merge, it'll automatically link back to your PR. So I think there are some benefits there, but so let me try to win you over as we keep going. Any other questions? Oh yeah, Alex.
Um, Sometimes there is situation when like Charlie creates a branch on top of Bob, and then Bob squash
I
everything.
have that example.
Okay.
Yep. His name is Charlie too. Okay, so a quick recap before we move on GitHub merge options. So create a merge commit. This one retains every single commit and then creates a merge commit if the branch is not currently at the tip of the branch you're merging into. Rebase and merge breaks the branch off, rebases it off of the current tip of the branch you're merging into, but still retains the granularity of each commit. And then squash and merge takes all the granularity, squashes it into one, and merges it, does a fast forward merge. So patterns at Ibotta, we enforce squash and merge on most repositories, and it produces history that looks like this. So I think that this looks really nice. I think that you can see sort of exactly what's happening. And Mike, this sort of goes to your like PR question. Like each one of these feels like a distinct feature, right? Each one of these also links out to a PR, which is great. Um, so it's like, here's a bug fix for offer promo image generation. Here's a new validation on campaign. Each one of these could, if with a merge, these could introduce, I see PRs with like 60 commits. So if you're looking at the commit history within develop or master or whatever your base branch is, it can be a total shit show in here, right? With this, it's each single piece that was part of a PR, which I think personally looks really nice. There's a PR link. Inside the PR, we use PR templates as well. So to Mike's point, you can go in here, see the tracker story, see the background. This PR was really nice. Shout out to Alex for putting a screenshot of the button he introduced. There's a lot of good information in here. And a developer that finds this commit years down the road would really have a lot of context and information about why we changed the code in this way. And the individual commits are still viewable within the PR, and the branch can be restored in the original state if needed. So this got squashed down into one branch. Is it important for me to know that Alex added an additional test for this PR long term in the main history of the branch? I would argue no. Like, this is related to the one feature that he was introducing. So I don't care that he added the additional test a day later, right? I do care that it's there as part of a feature. So there are some gotchas with rewriting history, and this is going to go to Alex's question. So remember our squash and merge from before. Our stuff looked like this. We created C9, so we squashed all of Bob's 3 commits into one, and it looked like this. So what would happen if someone branched off of our branch before we squashed and merged? So the branch wouldn't know about commits C2, C3, and C5, or it would still know about it, but those commits don't exist anymore, right? C9 is the only one that exists. Bob had 3 commits originally. He squashed it into one. So his 3 commits, the other branch still knows about it. So it looks kind of like this. So Charlie branches at C5. So this is the exact same thing that we saw before. But Charlie gets antsy and is like, I need to start working on your code before it goes to develop. So he breaks off at C5 and commits C10 and C11, a branch of the branch. So when Bob merges, he created C9, which we saw. This is the squash merge of all 3 of his original commits. But Bob's branch looks like this. It has first feature commit, second feature commit, last feature commit, and then his 2 commits that he made. His branch still knows about the pre-squash state. Charlie's branch, right? This is all Charlie's branch. I labeled them as blue because they originally came from Bob's branch. So yeah, this gold branch is all Charlie. Yeah, so the question is, what did Charlie do? So basically, what he did was he did a get checkout feature add behavior. So he actually checked out Bob's branch, but then he did get checkout dash B, or check out a new branch called feature add more behavior. So the base of his branch was add behavior, or he pulled it in, or whatever. But either way, his branch still has that logic. So to fix that, we kind of we need to help Git understand what's going on, because Git is like, I see this C2, C3, C5, but I don't know what that is anymore. Like it's not there. The merge looks weird, and you might get some weird merge conflicts. Like if you try to rebase off of develop, you'll still see that those existing commits from Bob's branch are still there, even though they're no ops. So to fix this, we need Git to understand what's going on. So what you can do is git rebase onto develop. That's the branch that we want to rebase from. The current base in our case is the old branch, Bob's branch. We want to rebase it off of develop. And then this is kind of a cool little feature. You can actually point at Bob's old branch, which may or may not still be on GitHub. You can restore it from GitHub back onto Origin through his PR. You can say feature add behavior. This was Bob's branch, and then the name of your branch. And what that will do is it basically says that other branch has gone away. It will remove C2, C3, C2, 3, and 5, and just replay 10 and 11, which were Charlie's commits. Or you can also just say replay the last two commits. The only thing that I added was 10 and 11, the last two commits. So you can say rebase on to develop the last two commits, and that throws away the rest of Bob's stuff, which will result in a nice clean graph that looks like this. Because we told Git about the old PR, or we said just replay the last two commits, my logic, it breaks the branch from all the way up at C1. It was attached on Bob's branch, so it didn't know anything about this other stuff. And it rebases it off of develop and replays C10 and C11. And it looks nice. Yeah. So this would, when would you want to run these commands on this slide? So what you would want to run this, you would want to run this before you merge. So let's say you have Bob's PR got merged. You're Charlie, you're ready to open a PR for your new logic. You would want to run this before you open your PR or as you rebase your PR within GitHub to point at develop. Because originally the base branch was Charlie's branch, and that's gone now. So it's like if you want to merge that code in, you need to merge that into develop, not into Bob's branch, because Bob's branch is gone. Nick.
And you have weird stuff happen.
Yeah. So the question is like, how do you know when that happens? Like if Bob went AWOL and Charlie doesn't know what's up. The number one case that I see in PRs here is you'll look at someone's PR and it'll be like 148 commits and they made 2 commits. And you're like, clearly the history on this is messed up because, you know, I can see that you only made 2 commits, but there's a bunch of other stuff on here that shouldn't be. Typically, that gives me an idea that you're based off of some history that's not valid anymore.
One more follow up.
Yeah.
When is it dangerous to run rebase?
When is it dangerous to run rebase? I'm going to go through that in just a sec. Check.
So, you know, some of your state is going to be local to your machine, and some of the is actually going to be up on the remote. When you're doing these kind of rebases, does just a git push work, or do you have to do a force or anything like that?
You guys are really good at foreshadowing my next slides. So I'm just going to go on. So after you do this, Git might tell you, hey, you can't do that. So I did my rebase onto develop, replayed everything. Everything looks great. I can tell from the Git log that everything looks nice. But if I just try to do a git push origin, you know, add more behavior, which was the name of Charlie's branch, Git's going to reject that. And it's going to say, this is not a fast forward. I'm not going to push anything to your repo. Updates were rejected because the tip of your current branch is behind its remote counterpart. Integrate the remote changes, hint git pull, before pushing again. See the note about fast forwards and git push help. What everybody does after this is they do git pull, which is not what you want to do. Yeah, so how does, if you didn't have access to the questions, if you don't have access to the branch, how would you know to only do these 2? The trick would be to look at the log, git log, and it would show you that you have 2 left. I don't think that mic's on, by the way. Yeah, so you basically are looking at how many commits have I made since I branched, and git log should tell you that. You can see the authors.
Got it.
But the but I think the cleaner way is if you have access to that branch still, if you branched off of it locally, you probably, like, if you created that branch not through the GitHub interface, you probably already have access to this at some state. And if you haven't pulled that, like, you're almost undoubtedly going to have access to this branch locally, even if it's been deleted from origin. So you can just say replay off of this. Okay. Yeah.
So with the rebase onto, I think I've been in a situation where I should have used onto, and what happens is that if you don't use onto and you just rebase against develop, is it the situation where you're just going to be forced to deal with 1,000 merge conflicts resolutions, and this will save you from having to do that?
Yes.
Okay.
So the reason why that happens is because what you're doing is the same rebase that you were doing before. So it was moving the tip of your branch to the current tip of the branch that you're trying to rebase off of. So like develop. But then what it's doing is it's trying to apply C2, C5, C6, the original commits from Bob's branch. But then you're getting merge conflicts because it's like, I don't know, Bob probably changed quite a bit of that area of code within his C9, the squash and merge commit. So it's like, it's trying to historically replay what Bob did and then squashed into that one commit. So by using rebase onto, it's basically saying, I know that this thing happened. I know that those commits aren't on develop anymore. So rebase my branch off of that. It's basically all this is doing is it's helping figure out what Alex was asking about. It's figuring out what is actually not on this branch, what is not on Bob's branch that you branched off of. And it figures out you had 2 commits. I'll just do this for you.
That's huge.
Yeah. So yeah, Machek's question is like, you can't just, Git's going to complain if you just try to push at this point. So, and then it tells you to do a git pull, which is not what you want. So it's warning you that history has changed in a way that it doesn't understand. It's suggesting a git pull, but that's not what we want, because what that's going to do is it's going to say, well, you're losing C2, C3, and C5. I don't know what happened to these anymore, but you're losing them. So just pull, and I'll bring those commits right back in for you, which is not what you want, right? Because we just rebase to get rid of those. So we basically just need to tell Git that we know what we're doing and we know that we rebased. So we can say, we can look at the Git log, make sure that our commit history looks correct, that C10 and C11 are on there. And then you can do git push force with lease, origin, feature, add more behavior. So git push force with lease, I'm going to tell you about in just a second, to the origin, and this is my branch name. Origin will now happily accept our newly rebased branch. So what the heck is force with lease? It basically checks to make sure that no one pushed anything else to your branch before you rebased. I went into a lot of depth in the first version of this talk, but we're running short on time. So the TLDR of this is basically use force with lease. And if you get a warning that looks like this, that you have stale info, someone else is committing to your branch and you don't know about it. So if you were to do git push -- force, it would just say, I know everything and I'm going to just push this up, and this is the true source of history. Like, don't even talk to origin, just accept my branch as the correct history. Force with lease, what it'll do is it will check first, like, was my add more behavior branch up to date before I rebased? And so if, say, you're working on a website and your designer comes in and commits some CSS change or something that you haven't gotten yet, it'll say, hey, there's something you don't know about yet, and you need to check out who else is working on your branch. This rarely happens, I think, because most of the time you're the only one working on your branch. But force with lease, I'm pretty sure in like the next major version of Git, -- force is going to default to force with lease. But for now, this is really handy. And in fact, I just have an alias in my Git config called pushf. So I just do git pushf origin feature add more behavior, and it automatically does the force with lease. If you guys want more information on that, talk to me after. Ben. Yep. Why did Git reject it? It's because we all would have had a really bad time if it would have let you do that. So we have protected branches on master and develop on our repos. commit history should never be rewritten on master or develop ever, because then everybody's notion of history will totally change. So you can force push your feature branches as much as you want, but it will reject. And I'm happy to hear that it did reject that, because we'd all be side-eyeing.
On the last slide, so
Is there any reason to not always use force with least with pushing? Yes, because I guess my thought is that like a force only needs to be used when history was rewritten. So if you're not rewriting history, I would kind of want to see something get rejected before I just always did force with least, but I suppose you probably could.
so if you did a force with lease and it got rejected, how do you at that point fix that? Because you can't get pull, because that's gonna try to grab stuff that you don't want in there.
Yeah. Wow, you're in some deep crap if that happens now. It's pretty easy to fix. What I would probably do at that point, if you were all up to date on Origin, because Git has like a remote and a local flavor, it's pretty handy because you could just delete your local branch if all of your changes were pushed up, and then that example, like the designer committed some CSS or whatever, right? You could delete the branch, start over, and then just rerun your rebase onto. You could also pull from Origin, do what it's telling you to do, pull from Origin, and then do your rebase onto as well, because it would just reintegrate those original commits from Bob's branch, and then you just say do it again, and it would do the same thing. Sonia.
Is force with least doing anything other than checking to make sure no one's pushed an additional commit? Anything else under the hood?
That's the one that's important. Yeah.
Okay, thanks.
Nick.
If you're sharing a branch with 2 or 3 people and you do the force with lease, the next time those other people try to pull that branch, is there awkwardness?
Yes. So the next time they try to pull that branch, Git will tell you like, whoa, our history has changed and I'm confused now. So you could do a git pull -- rebase from your branch. And what that would say is take whatever history they have as truth and then update our branch. That's one thing with rewriting history though. Like you shouldn't rewrite history if you're sharing a branch. Like if you have 10 people working on a branch and you're rewriting history, you're just going to have a terrible time, like because it's going to be constantly changing and stuff. So these are strategies that I typically use like when I'm ready to open my PR, or everybody's done and we're ready to like merge stuff in to develop. That's when I start like messing around with stuff. Because otherwise everybody has to know who's rewriting history, why are you doing this, that kind of stuff. So your commit history can be totally however you want it to look. My proposal is that you clean it up before it goes back into the shared code line. Any other questions on this? Okay, let's keep moving. Okay, so that is kind of the main meat of that piece. So hopefully you guys have a better idea now what happens when you merge, when you rebase and merge, when you squash and merge. You can develop your own opinions on which ones you think are the way that you like it. Again, there's schools of thoughts. There's not like this is the right way to do it, this is the wrong way to do it. My proposal is that I really like looking at commit history that's very noted by features, but there's also ways to work around that as well. Like if we're doing a giant the Rails 5 upgrade and I want a bunch of commits, I can merge that at the command line without having to do a squash and merge. I only enforce that stuff like the organization enforces that at the PR level, so that it's like super easy for the 99% case where you're breaking off a feature, working on it for a day, 2 days, 3 days, and then merging it back in. But if there's ever a case where we have like a giant epic branch and we want to retain that, come talk with us, because you can do that from the command line. Any other questions before? So I'm going to go into some PSAs, stuff that I see happening on our in our like monolith repo and a few others. And then I'm going to run through a couple of tools that are really handy to use, some commands that people noted in the survey they weren't very familiar with. All right. PSA, you almost never need to merge the same branch into itself. So this is some commit history I saw recently where I'm looking at the develop branch, and then there's a merge develop of Ibotta into develop. Why do we need to merge develop into develop? What happened? The lag is really bad for my jokes. Well, my jokes are bad to start with, but anyway. So what happened here was this was the last local commit that this person had on their branch on develop. So when they locally went git checkout develop, if they were to do git show, what they would see is this was the last thing that they knew about. Then they made this commit locally. So they made this code change locally on develop, git add, git commit, and then they tried to push. But what happened was that this PR got merged between the time that they had updated develop and made this commit. So this was basically, I think this was Hamilton hitting squash and merge on his PR. So what happened when this person tried to push, they got this message that said, failed to push some refs, just like we saw before. It's basically saying our history has diverged and I don't know what to do about it. In this case, because we're dealing with develop, we don't want to rewrite history at all because everyone's going to have a bad time if we do that. We never want to force push develop like with our other branches. But what we do want to do is we want to integrate the missed commit and then replay our commit, right? So we missed Hamilton's PR, and this happens a lot more often now with so many people working in the monolith. But we want to basically bring that commit in, replay our commit, and then push it to develop. So this is really easy. All you have to do is git pull origin develop -- rebase. So this was similar to what we were talking about with Nick's question. So what this does is it basically says, I know that I'm missing something from origin. I don't know what it is, but I know that I've also made an additional commit. So what this will basically do is it will replay our commit after the upstream commit. So with this, all it does, we say git pull origin develop rebase. What it does is it plays Hamilton's commit in here, and then it brings in our commit that we wanted to make locally to develop, and then that goes away because we don't need to merge anymore. Now Git will happily accept that branch without any force push because the histories match both upstream and locally. It's like, I see this commit. This is a new commit, but it's a fast forward. It's something new that no one else knows about yet, so push it up. So if you ever get a warning about, you make a commit locally and then you try to push and it says you can't do that, that just means that someone else has pushed a commit that you need to integrate into your branch. You could also do a git pull without the rebase piece, but what that will do is it'll create a merge commit, which is what happened initially. It basically does a merge because it's like, I don't know what happened before and after, but I'll try to do my best to merge it. A rebase just says, replay it, apply my diff. Any questions on why you almost never need to merge your own branch into itself? Okay, so I'm going to run through some other Git tricks as well. We're doing great on time. So the first one I'm going to go through is git add -p. How many people know what this does? Git add by patch. About half. That's about what people said on the survey. So this is another tool to use instead of or in addition to git add dot. So many people's workflow is git add everything in my repo, or git add the app folder, or git add the spec folder. This stages those files to be committed. So what git add -p does is it steps through each file patch by patch and asks you what pieces of this do you want to stage. So imagine a change at the top and the bottom of a file, but they're not related to the same thing that I want to commit. So this is an example on a README. This is like line 3, and it's a change up top. And then down here at like line 20, there's a change at the bottom. And say that I do want to commit the change at the bottom, but I don't want to commit the change at the top yet. Maybe I'm still fixing a spec related to that or something. I'm not ready to commit push it yet. Git add-p will actually step me through each one of those hunks. So a hunk is like a term within diffing, and that's what we actually saw with these two separate things that came up in the diff. And it steps you through hunk by hunk and asks you, do you want to stage this to be committed? So git add-p will first ask, show me the change up top, and it'll say stage this hunk, and then a bunch of different commands you can do, including the question mark, which will tell you what they all do. But I basically say N, no, I don't want to commit this yet, or I don't want to stage this for commit. And then it'll ask me about the change at the bottom. Do you want to change this one? And I can say, yes, I do want to change, or I do want to stage that. So then if we were to run a git status, we see this kind of interesting state where it's like, there's some things from readme.markdown that I do want to commit, but there's also some stuff that I don't want to commit with this commit. So this can be really handy when, let's say you're working on like a gem file, like you made some changes in the gem file, and you're like, I know that the AWS gem upgrade is working well, but I know that the Zebra gem is not working correctly quite yet. Well, you can use git add by patch to actually add the AWS part, but not add the Zebra part, push it up to origin, and then continue working through the issues with the Zebra gem. Any questions on git add by patch? The schema sometimes can be handy for this too. If you have a really out of date database and you run db migrate and like you don't have a bunch of tables and it's like a shit show and you're like, I'm just adding a column. Why is this happening to me? You can git add db schema -p, and it'll step you through the schema, and you can just add the one column that you're actually touching, not everything. Lots of questions.
More of a comment actually, but one thing that I use a lot, so especially if you have files that new files that aren't tracked yet and you don't want them to be tracked, but you know all the modified changes should go in, instead of doing a git add, if you do git commit -a, that automatically adds all modified tracked files, which is neat.
Is the add by patch, is that going to step you through every single unstaged file?
Yeah. So the other part of his question was, do you have to step through everything? So you can actually pass it a file just like you would before. So let's say you wanted to add by patch everything in the schema file, but nothing else. You could just say git add db schema, give it the full path to the file -p, and then that will do it. So git add always takes what's the path that you want me to look at. So you can git add by patch, and then you could say, git add all of app. So git add app /, and it would add everything in app and then everything you had staged out of the other file. If you do git add dot after that, everything you just did was lost, because git add dot, you're basically, that's a directory path, right? So you're saying git add everything you can see from here that's tracked or untracked.
This is just another comment. I use a visual editor sometimes called GitX that does the same thing, where it shows you a file with all the patches in it and lets you stage or discard them or do the whole file all at once. It's really helpful.
For the visual folks, yeah, that's great. I was actually surprised. There was like, I think it was about 25% of people were using some kind of UI for GitHub. Cool. Any other questions on adding by patch? Okay, so next is revert. And I'm going to talk about this from the context of reverting squash commits, which is like what we have to do on the monolith sometimes. So with squash and merge, this is actually pretty easy. So this was an example actually from yesterday of a commit that we needed to revert. So this was the offending commit. And then all we had to do is basically git revert that one commit SHA and push it to develop. That produced this, which is pretty handy. It's, revert along with the PR link and everything. And it generates a new commit hash, this 43BAA. So then we obviously want to figure out what went wrong with that and reintegrate that change, because we still need to accomplish the story, right? So basically from there, we can check out a new branch where we revert the revert, git revert the revert commit in this case, and then go along our way. So reverting the revert just is as if the revert never happened. which is kind of strange, but it's the best way to do it. Questions about reverts? Mike.
If you're not doing the squash, is this really difficult to revert a PR?
So you, in that case, you would actually revert the merge commit. I find it really confusing, like, because you're still going to have, like, in that example, C2, C3, C5, then the merge commit, then you revert the merge commit. And so you can like run into those other things. It's not clear, like, was this reverted or not? Like, I think it's still like a one SHA revert. So you would revert the merge commit and then revert of the merge commit. But I find it really nice when you look at the commit history and you're like, here's where it got merged, here's where we reverted it, and here's where we re-added it. Like,
Yeah.
it's 3 commits and it's very obvious, in my opinion, what happened. Reverting merges on the command line is very hard. GitHub makes it easy, but doesn't give you information about what it's doing. So there's a revert branch button, or revert PR, I think, within the GitHub interface. But yeah, it doesn't do like git revert the merge commit. It does a lot more than that. And I personally think this is another reason why squash merging is really nice.
The only issue I have with this when you're doing the revert is it sometimes might be helpful to have that commit history for that branch if you're trying to trace the issue.
You still have it in the PR.
Oh, okay. That makes sense.
You're not losing anything. You're just keeping mainline really nice and clean. Any other questions on reverts? Okay. Git bisect. So this is a really, really handy tool, and I think about like little less than 20% of people have known how to do this, and it is so helpful. It helped. We walked through this on internal products like about a week ago, and several people have told me that they've used it since. So what git bisect does is it uses binary search to find a given commit that introduced a bug. And the Wi-Fi is real bad, so we'll have to see if this GIF will actually work. But if you guys remember from your algorithms class, binary search, basically what it does is it cuts stuff in half. It tries to see if it's making progress, cuts it in half again. So in this case, we're looking for 37, I believe. And with binary search, we're able to find it in about 3 steps there, versus sequential search, where we look at each one of these things. We have to look at every single number until we find the number that we're looking for. Imagine that these are each commit messages, right? That's what git bisect will help us with. So instead of saying, is it bad here? Is it bad here? Is it bad here? Is it bad here? It'll actually walk us through doing a binary search to try to see where a given issue was introduced. So we'll walk through an example. This is another reason why it's nice not to have a million commits in your develop branch. Steps. So basically we tell Git that we want to start bisecting. We mark a commit that we know is good, which is typically, or like where the problem doesn't exist. Think in the case of like a monolith deploy, I know on the previous deployment tag, this issue didn't exist. And I know on the current deployment tag that it does. Then you mark a bad commit, and then it walks you through finding where the bug was introduced. So this is a good example. I linked to the source because I totally stole this from someone's blog, but I thought it was a really easy way to understand it. So this is a really simple example where we have this text file, and it says row your car gently down the stream. And what we want to figure out is who changed boat to car. A more realistic example is like, maybe you can write a failing test for some issue that you're seeing in production. You can use bisect to figure out, when did this test start failing? Like, what commit actually introduced this? So that's annoying. And if we were to look at the log, there's actually quite a few commits in here, and we're like, oh man, there's so much stuff. Like, I don't know when this got introduced. So git bisect to the rescue. First, we tell Git that we want to start bisecting by git bisect start. We mark the commit where we know that things were okay. So when we added the word boat, I knew that looked good because it said boat instead of car. So I say git bisect good, and then the commit hash of the commit where we knew that things were working. Then we say where we know it's bad. So git bisect bad. this is like master or the current deploy. We know that it doesn't work with the current one, and it did back at this other point in time. So git bisect bad, and then that commit hash. So then Git will start walking us through a binary search of the commit history to figure out where the problem existed. So it says bisect, 2 revisions left to test after this, roughly 1 step until we find the offending commit. Here's the commit hash of the one that we're looking at, changing the word boat to car. Okay, this looks like it could be bad. But what we do is we either run our test, or in this case, we look at the test file and we see row your car gently. So we know that in this case, the bug exists. So we want to say git bisect bad. So then it says, okay, I bet we can find this in roughly 1 more step. So adding the word gently. Okay, well, row your boat gently. This looks good. So git bisect good. And then Git will tell us, here's the commit that started causing this problem. This is the first bad commit. Here's the commit message. You can go shame whoever did it, or talk to them about what went wrong. So this was actually really good. A concrete example of when we did this was the other day. Shannon was like, "Hey, I'm getting all this weird output when I run log output when I'm running my tests." And I'm like, "That's weird. I see it too." And so instead of stepping through sequentially each of the commits and seeing like where it was, I said, "Well, I know it was good before I reintegrated develop into my branch, and I know it's bad now." And it stepped through. We found the commit, and then we were like, oh, "Okay, something with this commit started causing this problem." We figured it out. We reverted that thing first, got things working again, and then we figured out what the problem was. So instead of having to look through everything, dive through all the code, binary search helped us to find the right thing. Questions on bisect? Yeah, questions on anything else? We have 2 minutes. I listed some resources here. The Git book, this is the git-scm.org, has a lot of really good information. There's also a good book on Git plumbing that talks about how Git tracks everything. The thing day-to-day to use is git help command name. So you can do git help rebase, git help bisect, git help anything, and it'll show you the man page specifically for that thing. Oh, that's cool. Git bisect can do it for you if you have something that does, like, I'm assuming a non-zero exit code, Justin. Git help bisect will tell you how to do that. That's pretty neat. That's all I got. We can take any questions that you guys have. Thanks for listening.
Yeah, thanks, Ben. That was great. One comment to push the idea of a squash and merge, although I can't convince my own wife, so take that with a grain of salt. But one thing that you get with Git is you have a complete copy of the repo. So if you're on the bus working with no Wi-Fi, it's really nice to have concise, clear merge, rebase merge commits that you can read up on all the issues that were going on and not have to go to GitHub. So it's nice having the complete history that is of the relevant information available at your hand.
I swear I didn't plant him. Any other questions? I should have also put my name as a resource on there. Oh. You lose tags. Right. So when it does a squash merge, the way that the PR can still retain all of the commit history is that branch was basically orphaned. So some weird things can certainly happen with that. That's why I think the pro of the just merge and have your commit history look like whatever is that it's really hard to sort of do the wrong thing. But with this stuff, especially with force with lease and stuff, you're not, and our protected branches, like, you're not going to mess stuff up. So try it. And if you have questions, I'm a resource as well. I know a few people on the team pull me over when they like run into catastrophes. Tagging on feature branches is weird anyway. Yeah, if you're creating Git tags on your feature branch, you're probably doing it wrong to start with, in my opinion. All right, guys, thanks a lot.